Hi folks, Mr. Long here. We're going to do a mortgage problem in this screencast, and we're going to talk about a few key ideas that relate to mortgages. The first one is this idea of that in law in Canada, mortgage has to be compounded or calculated semi-annually. Okay, interest has to be compounded semi-annually. And this is a bit of a problem, though, because our payments aren't semi-annually. Payments, on average in Canada in general, are made every 2 weeks, bi-weekly, although they can be weekly, or monthly. That's the most common one. My apologies, there's an extra M there. So what we have to do is calculate what's called an effective interest rate per payment period. So it involves a little bit of extra math. Okay, so here's our problem. It seems quite simple, and it is reasonably simple. So you buy a house for $200,000, you put 10% down, interest is 5% per annum on your mortgage. What's the monthly payment for a 25-year mortgage, and how much interest will you pay in total? Oh, by the way, that $200,000, is that money today, or is that money in the future? Well, it's money today. Since it's money today and you're paying it off over time, it's a present value annuity. So whenever the payments depend on the present value, that's a present value annuity. Whenever the payments are trying to create some amount in the future, that's a future value annuity. Okay, so here we go. We've got a house for $200,000 and we've put 10% down. Let's figure out the effective interest rate. So here's what we've got. We've got 5% interest per annum. If it's being compounded semi-annually, that means we have to divide by 2, which is 2.5%. So semi-annually means twice a year. So we get 2.5% interest, or we're charged 2.5% interest every 6 months. MOS is going to stand for months. Or MO, actually. Let's do MO as months. So MO is months. But that's a problem because, in fact, our interest, our payments are every month. So what we have to do is, how much is that 2.5% every 6 months for a year? So we know it's 1 plus I to the n, which is 1 plus 0.025, or 1 plus 2.5 divided by 100, squared, because it's compounded twice in a year. And that gives us an amount of 1.0506, or 5.06% for a year. Okay, so whoops, that was an eraser. I better write that again. %6 per year. Okay, so right here, 5.06% in a year. So why is, like, doubling of 2.5 is 5, but why is it more than that? Because it's compounded. There's interest on the interest. It's a feature of exponential growth. So that's the percentage we get for a year. Now we have to take that year and bring it back to 1 month. Well, how do we do that? We know that 1.0506 to the exponent of 1 over 12 will give me 1 month's worth of interest, right? Because this is exponential. So instead of dividing by 12, it's exponential, so we have to do the exponent of 1/12. So that gives us 1/12 of a year. So when I do that calculation, I end up with 1.00412, which means 0.00412%. Sorry. Decimal 0.004. So 0.04%. Sorry, folks. 0.4. Oh boy, this is a bad day, or a bad lesson. So I have to move the decimal place twice. Mr. Long needs to go back and learn about place value. 1, 2. So 0.412% every month. Okay, that's what it works out to. 0.412% every single month. And which makes sense, right? That's what's going to work out to, if you just do a rough calculations, 4 times 0.4 times 12 is 4.8, right? So it's close to 5%. Okay, so it's 0.0412% per month. That's the effective interest rate. And so now we need to put our information into solving for a payment. So our interest we've already got is 0.00412. That's the interest as a decimal every month. And our number of payments is 25 years times by 12 payments per year, which will work out to 300 payments. Oh, our present value of our annuity. Remember we put 10% down? So our present value of our annuity is the $200,000 purchase price minus 10% of 200,000. Well, 10% of 200,000 is obviously 20,000. 200,000 minus 20,000 is 180,000. So we're going to borrow $180,000 from the bank. So that's the present value. That's what those payments are based on, that present value, the day you buy the house for $180,000. Okay, this is what you give up in cash. That's called a down payment. So you only have to borrow $180,000. So what we do is we substitute everything into the equation. So we're going to end up with, so PVA is going to be 180,000. And that's going to equal PMT, which I don't know, I need to solve for. Then it's going to be 1 plus 0.00412 to the exponent of 300 minus 1. And we're going to times that, divide by that, times that by 1.004412 to the exponent of negative 300. That's hard to see, sorry. And, oh, by the way, that negative 300, which I'm going to highlight here, that takes this right here, this formula right here represents the present value or the future value of the annuity. So what we do is we calculate the future value of all those payments to the end of that 25 years. And then we use this calculation. See, it's a minus n, or I could have this right here into the bottom over here. But this minus n moves it back the 25 years. So I calculate the future amount and then move it backwards to today to make it present value. And then I have to divide all of that by I. And I is decimal 0.00412. So when I calculate that, and I'll just put a box around it, this whole thing right here works out to 241.72. So I'm going to write that down in black down here. So I have 180,000 equals PMT times 241.72. And I'm going to put a big box around that because I've run out of space here. And I think you know how to solve this equation. You divide both sides by 241.72, and that will give you your monthly payment. So let's go on to the page. So the payments, PMT, happen to work out to $744.65. Okay, $744.65. And then we multiply that out by our 300 payments, and it works out to be approximately $223,300 $395. So that's what we paid for the house. Right? This is what we paid for the house. Now, the mortgage portion of the house is only worth $180,000. So what represents the difference between these amounts? Out of pocket, we paid $223,395. Now this one right, by the way, that's a very low interest rate, 4%. That's similar to what the rates are today, and historically they're very low rates. So there was a time in the early 1980s, for example, where interest rates for homes was approaching, or it was around 20%. So interest was much higher. Not that many years ago. Anyway, so that's $180,000 right there. In total, we have to take our payments, which are $223,395. Take off how much the loan is worth, and that difference represents our interest. And so in this case, our interest is $43,395. And that's how much interest we paid for in total on that home. And again, there's a whole bunch of other things. This really oversimplifies things because you often have to negotiate your mortgage some people just go on a floating rate from year to year, so their rates are always changing. Some people, like me, lock in for 4 years or 5 years at a time. There's a lot of different options, but this is assuming that you bought the house and you kept that 4% interest rate for 25 years, which in reality won't happen, but it gives you some idea what the process looks like. Okay, so what I would encourage you to do is to go back over this question. By the way, this question is very similar to the assignment questions on mortgages. The key thing here is, in the hard part, is the equivalent monthly rate, the part that you have to do. And just go back over that, maybe try and do this question on your own without looking at the solution, and then tackle that assignment. Okay, folks, have a good day.